Hi everyone, welcome to MASH Math. Today we are going to study from class 10, chapter 3, pair of linear equations in two variables, exercise 3.2, question 4. Which of the following pairs of linear equations are consistent, inconsistent? If consistent, obtain the solution graphically. So the question is, the pair of equations are given to us. We have to find out whether it is consistent or inconsistent. If it is consistent, then only we have to find the solution graphically, because if it is inconsistent there is no any solution, and therefore if it is consistent only we have to prepare. And already I have explained to you what is the meaning of consistent and inconsistent. If you go to at introduction exercise 3.2, I have explained to you the meaning of consistent and inconsistent. So when the equations are given to you, you have to find the ratio of the coefficients. If the condition is first two ratios are not equal, then will get the graph of intersecting line, where we will have one solution, one common point where the lines intersect, and this type of equations we call it consistent. So where we get the solution we call it consistent. So if you find in the equations all the ratios are equal, then we get the coincident line, where number of points we have on this and many solutions we get it, and so this equation also is consistent. If you find where the last one is not equal to the first two, then we get the parallel lines where we have no solutions, because both the line doesn't touch each other in any point, therefore no solution. Those equations will be called inconsistent. And if it is inconsistent, here they are asking us no need to prepare the graph. If consistent only, we have to obtain the solution. So let's do it quickly. Exercise 3.2 question 3 we have done to find out consistent and inconsistent. So same way we have to do. So we know that this is A1, this is A2, this is B1, and this is B2, and this is C1 and C2. So let's write down the ratio here. So our A1 is there, 1 is there, and A2 is 2 here. This is our A2, so 2. Let's compare first to both. This is here 1 we have, and here B2 is 2 we have. So both are same. So let's go for the third one now. So third one is 5 upon 10. 5 upon 10. So if we simplify this, 1 times 5, 2 times 5. So we have got all three same. So the condition is, our condition is A1 upon A2 is equal to B1 upon B2, which is equal to C1 upon C2. So therefore this equation is consistent, because what is the condition? When all three are equal. So when all three are equal, a graph will be coincident line will be getting. Therefore this is consistent. Therefore this equation is consistent. You can write this equation is consistent. If it is consistent, then we have to plot the graph. For graph, we have to find at least two solutions to get the graph. So let's plot the graph. Our equation is this. Let me write down the equations. That is x plus y equal to 5. Another is 2x plus 2y equal to 10. So we plot the graph. At least two solutions we need. So here will be x, this is y. So let's take maybe x value we will take as a 0. So if we keep x as 0, y value we will get it 5. Now let's take x as 1. So if we take x as 1, here we have 5, right? So this 1 comes this side, it will become minus 1. So then y value what we will get? We will get 4. So same way here, let's take y as 0. So if y we are taking 0, if y becomes 0, then the whole thing will become 0. So we will get 2x equal to 10. So we will get 2x equal to 10. So that means x will be 10 upon 2, we'll get 5. So x value will be 5. So now let's take maybe any value you can take. So y I'll take as a 2. So if I'm taking y as 2, then maybe we'll get 2x plus 2. In the place of y I'm taking 2. 10. So 2x plus 2 2s are 4. So 2x equal to, this 4 goes there, minus it will become, so 2x equal to 6, then x equal to 6 upon 2, 3. So x value I am getting 3. So now the solutions are ready, so let's plot it in the graph. So this is our graph. So we have the x-axis here. So we have the x-axis, x dash, y-axis and y dash. So let's plot the graph. So first we have 0, 5. So 0, 5. For x 0 is here, for y 5 is here. So point will be here, 0, 5. Next 1, 4. So 1 for x is here and for y 4 is here. So this will come this direction. 1 will come this direction, so both will meet at this point. So 1, 4. So let's draw the line of this. Okay, so now this is our equation, that is x plus y equal to 5. This is x plus y equal to 5. So now let's plot for this. 5, 0. 5 is here, 0 is here only. So 5, 0. And then 3, 2. 3 is here, 2 is here. So 3, 2. So if we plot the graph for this, then the line will be on this only. So line comes on this point only. So that means, so this will be another. Both the lines are coinciding. So all these points are there. So many solutions we have here. Solutions here. All these solutions are on this line only. This line also, if we extend, it will be coinciding only, both the lines. Coinciding. We already said this equation is consistent because this will be coincident line where we have infinite number of solution. So we have infinite number of solution. So now let's do for the second one same way. Okay, here also we have to find out whether it is consistent or inconsistent. So let's do, this will be our A1 and this will be our A2, here B1, B2. So let's do, this is 1 we have, here it is 3. Then here 1 we have, but here minus it is, so minus 1 will write, here minus 3. So minus minus gets cancelled. So we have 1 upon 3, here also 1 upon 3. So both are same. So now let's compare the third one. So that is 8 upon 16. Now 8 upon 16, if we are simplifying, 1 time 8, 2 times 16. So that means we are getting here 1 upon 3, 1 upon 3, but here 1 upon 2. So that means this is not equal. So that means what is the condition we are getting? Our condition is A1 upon A2 is equal to B1 upon B2 and not equal to C1 upon C2. So that then what will be the graph we will be getting? You see here, when this is a condition, we'll be getting parallel lines and there is no solution and it will be inconsistent. So this is this equation. Therefore, this equation is inconsistent. There is no solution. So if no solution, no graph. So let's do the third one. Third one also same way we have to do. This is 2 upon 4 equal to, here 1 we have and here we have minus 2. So let's compare. If we are simplifying, 1 times 2, 2 times 2. So 1 upon 2, here also 1 upon 2. But here minus 2 we have, here we don't have minus. So this is not equal. So therefore our condition is A1 upon A2 is not equal to B1 upon B2. So if this is a condition, what we will get? See, when this is a condition, it will be intersecting lines. There will be only one solution and it is consistent. So therefore, this equation is consistent. If it is consistent, then we have to obtain the graph for it. To obtain the graph, then we have to find the solutions. So let's write down the equation, that is 2x plus y minus 6 equal to 0. And here 4x minus 2y minus 4 equal to 0. So for graph, we have to prepare the box because we need at least 2 solutions to prepare the graph. So this is x, this is y, x and y. So now if we keep in the place of x 0, then the whole thing will become 0. Then what we will get? Then we'll get y minus 6 equal to 0. So then y equal to minus 6 comes this side, it will become plus 6. So y will get 6. So now next, if I take 1, then here it will be 1, right? Then 2 ones are 2. So let me put it here. So 2 ones are 2 will be plus y minus 6 equal to 0. Then this 2y, let this plus 6 go this side. Minus 6 comes to this side, it will become plus 6. So y, let it be here only. This plus 2 comes to this side, it will become minus 2. So then y value will be 4. So y value will be 4. So same way we'll do it here. We'll take here maybe y as a 0. So if y is 0 means the whole thing will become 0. So then what we will be left with? 4x minus 4 equal to 0. 4x minus 4 equal to 0. So 4x equal to minus 4 will become plus 4. X equal to this 4. When it comes here, it will become division. So we will get x value as 1. So now let's take maybe y value as a 2. Then if you are putting in equation 4x minus 2, y value as a 2 minus 4 equal to 0. So 4x minus 2 2's are 4. This is minus 4 equal to 0. So let's take 4x minus 4. This minus 4 comes here, plus 4. Then 4x equal to 4. This minus 4 comes this side, will become plus 4. So that means we'll get 4x equal to 8. So that means x equal to 4 will become division. So 2 times we'll get. So x value will be 2. So we got the 2 solutions. So let's plot it in a graph. So we have graph here. So we have x-axis. So let's plot it. First 0, 6. So we have 0 here. Y-axis 6 is here. So this is 0, 6. Then we have 1, 4. On x 1 here and y 4 is here. So 1 is here and 4 is this direction. So 1, 4. So let's draw the line for this equation. So we have drawn the line. This is of the equation, that is 2x plus y. This is 2x plus y minus 6 equal to 0. Okay. So now let's do the graph for this 1, 0. So 1 is here and for y 0 is here only. So 1 comma 0. Then we have 2 comma 2. So 2 is here and 2 is here. It's the point 2 comma 2. So let's join these 2 points. So we have intersecting lines, and both the lines are intersecting at common point, that is 2 comma 2. So our x value is 2, y value is 2. This is the solution, one unique solution where both the lines are crossing or intersecting at one point. So now let's move for the fourth one. Fourth one, same way we have to do it. So let's find out. This is 2 upon 4. This is minus 2 and this is minus 4. We cancel 1 time 2, 2 times 4. This is minus get cancelled, 1 time 2, 2 times 4. So we got 1 upon 2, here also 1 upon 2. So both are equal. So let's compare the third one now. This is minus 2 and this is minus 5. So now if you see, this is minus gets cancelled, but this is 2 upon 5. Here we have 1 upon 2, but here we have 2 upon 5. So which is not equal. So therefore our condition here is A1 upon A2 is equal to B1 upon B2, but not equal to C1 upon C2. Therefore this equation is inconsistent, because I have told you that when this is the condition, the graph will be parallel line where there is no solution, so it is inconsistent. That's it. Thank you. God bless.